Next up, Pei Wang is going to talk about motivational management in AGI systems. Again, questions at the end. So.
I guess I show up at the wrong time just because someone just said motivation is simple. Anyway, I'm still going to talk about that. Many people have said that AI system or AGI system in general are goal-oriented, and some people use other terms. Basically, as far as this discussion goes, it's about more or less the same thing, meaning that the system's action serves certain purpose. Okay? They're not completely random, they're towards certain destination or direction. And technically, of course, their goals are used likely as in planning and decision making. The usual assumption in this field, made by many people, of course not everyone, but is that the designer of an AGI system will decide the system's initial goal. Some people call that super goal, whatever, which will remain constant all the time during the system's lifetime. And all the other goals are derived recursively as sub-goals or derived goals, whatever you call it. They serve as the means towards the initial super goal. And also many people assume that AGI can achieve its goals by choosing the actions properly or accordingly. But according to my theory about intelligence, which I will only very briefly summarize, the situation is slightly different. My working definition of intelligence is the ability for a system to work with insufficient knowledge and resource with respect to its problems or goals. That means the AGI system never knows everything or never has the resource to think about all possibilities. Otherwise, to me, that's just computation. That's not the AI I'm talking about or I'm studying. But on the other hand, it doesn't mean in that situation the system is hopeless. The solution I think both found by nature and also trying to find by us is adaptation. That is to learn from experience and also use what I call relative rationality. That is to always try to find the best solution under the restriction of available knowledge and resource. So the following discussion is under this working definition of intelligence, which I know is not shared by everyone here. So, but anyway, let's assume that's indeed the case, or that's the goal of some of the AI researchers. And under that situation, what we can say about the goals of the system itself. First, the initial goals. The initial goals were sometimes called given goals or input goals. Whatever we call them, they're not something that's chosen by the system itself. It's given to it or imposed on it, usually by its designer, sometimes by its user. And also the system's design puts restriction typically on the form of the goals, but not on its content. I don't think really someone can really design a system can only have, say, nice goals, never have any evil goals. Because to me as an engineer, in terms of representation, well, you cannot really tell the difference for in many of the situations. But of course, you can limit the form, the shape, or the representation format of a goal from an engineering point of view. So in that sense, my conclusion is always systems intelligence is to a large extent independent to its initial goals. To separate things, they have some relationship, but the intelligence system is not necessarily nice or necessarily evil. And also, well, that thing, many people I guess have mentioned that before. But there is one thing that many people have ignored or simplified too much to me is goal derivation. Or the process from in which the so-called sub-goals are derived from the given goals recursively. First, clearly, many goals is so brave or so general that cannot be directly achieved at all. So you have to kind of like cut it into smaller pieces going through a sequence of sub-goal or derived goal, whatever you call it. But that process is based on the current belief of the system, okay? Which, especially according to my working definition of intelligence, which can be wrong, which actually is often wrong. So what's the conclusion? The conclusion is goal derivation in an AGI system, to a large extent, is a historical relation. It's not necessarily a logical relation. That is, a goal A is indeed derived from goal B, but it doesn't mean it's logically implied by goal B. Okay? So it will lead to a very important phenomena actually in psychology, which is called functional autonomy, which means the derived goals gradually are going to be treated by the system more and more very similar to the initial goals themselves, okay? Even though the historical relation is still there. So what that means? It means several things. For example, goals are not necessarily consistent with each other in a system at a given time, which have two aspects. One aspect is the logical aspect. That is, the achieving of one goal may actually rejecting the achieving of other goals. They're going to block the others. Okay. Another one is from a resource point of view. They compete for the limited resource. So we can clearly find a lot of examples of that among human beings. What I'm saying is it will be true for AGI too. So another thing is when a decision is made, no matter how many goals are there in the system, because of the knowledge and resource restriction, actually only a small number of them will be taken into consideration. Okay? You cannot really consider all possibilities. So to me, AGI goals in AGI system, especially, for example, here I'm talking about a concrete example of my own AGI system, NARS, which I don't have to talk about at all, but some of you have heard about that. What's the situation about goals in that kind of system? Well, at any moment, the system's action depend on usually not a single goal, but multiple goals. Okay? And second, those multiple goals are not all the goals in the system. Actually, it's a very small subset of them, selected according to many factors, especially history and context. And also, all the existing goals depend on the initial goals and the history of the system, but neither of them alone. Which means some of the common assumptions in this discussion have problems. Okay. For example, the initial goal, according to this kind of structure, will not fully decide the behavior of the system. And also, it's not proper, according to my opinion, to assume the system has a single goal. Or some people say, oh yeah, there are more than one goal, but we can treat them one by one. But that's not true. So, and also the existence of a certain goal in the system does not mean it will be pursued by the system at the price or the cost of all the other goals. For example, many people have mentioned that a truly intelligent system will develop a goal and try to get as much resource as possible, which is true, which I believe will be the case. But it doesn't mean the system is going to take that one as a dominating goal or the only goal at the cost of everything else. A truly intelligent system is not going to do that, even though that goal indeed exists in the system. Another thing is, even if there is a goal in the system, doesn't mean the system really will be able to achieve it. Okay? So that's two separate things. And also, on the other hand, you see clearly that means a lot of danger. That means that there are a lot of problems when we try to control the system's behavior. Okay? Can we restrict the amount of possible goals? Yes, we can, of course, very simple. But if we do that, we need to pay the price in the system's intelligence. So just to make sure I finish on time, conclusions. The goals of the AGI system is not fully determined by the initial design. It's designed both by the initial goal and the experience of the system itself. Okay, both of them. So, which means also if we really want to control AGI, if we really want AGI to be friendly or human friendly, if we use that phrase, I don't think that can be done by design. A key word we are all familiar with is education. To me, that will actually play a bigger role than design on that aspect. And also in the paper, I have argued that the goals are persistent in AGI system, simultaneously changing and mutually restricting, which I'm not going to repeat because it's in the paper already. And also, this part is already implemented in the current prototype of NARS. If anyone is interested, I will show you a demo and how it works. Again, we don't have time to do it here. And so finally, it means to me that proper motivation management in AI is a challenge, but it's not impossible. Yeah. So maybe we can say it's easy. Okay? It can be done. It's not a disaster. But I guess it's not as simple as many models assume. For example, there is a single goal. If we can control that, we can control the system. I don't think that will happen.